Hello student, welcome all of you. This is lecture for B.Sc.SY student and semester is third semester, paper group theory and paper number is 7th paper. Students, in previous lectures we have already discussed about the uniqueness theorem. So in group, if there is a inverse exists, then it is unique, and if there is identity element exists, then it is unique also. So these two uniqueness theorems are very famous and will ask in exam. So you try to understand yourself. We have already discussed. Now we are going to discuss one theorem, and that is prove that AB inverse is equal to B inverse A inverse. AB inverse is equal to B inverse A inverse for all the AB belonging to the elements of G. So in word we can say that the inverse of the product of two elements. So here A and B are element of G. So product of AB, firstly take product of AB and after that take the inverse of them, is nothing but inverses taken in the reverse order. Inverses taken in the reverse order. So we have to prove this. AB inverse is equal to B inverse A inverse for all the AB belongings to G. Now we start its proof. Suppose A and B are the elements of G. Actually it is given. For all the AB belongings to G means obviously A and B belongings to G. So suppose A and B belongings to G, A and B are any two element, and if A inverse and B inverse are inverses of A and B respectively, then A inverse A is identity element. Obviously we can write in this way because E is an identity element. Similarly, B inverse B is equal to E is equal to B into B inverse. Okay, now AB into B inverse A inverse. We are trying to find what will happen if we take the product of AB and B inverse A inverse. So here I can write like this: AB B inverse A inverse. So A B belongings to G, A inverse B inverse belongings to G. So by definition of group, there is associative property must be hold, and so I associate the B inverse to AB. Also I can write A into B inverse into A inverse isn't it? Then this B into B inverse is identity element E. So A into E into A inverse. So this is equal to A into A inverse, and A into A inverse is nothing but identity element E. So here, if AB be the any element and B inverse A inverse be the any element of the group G, and their product is unique, their product is identity element, so meaning is that this element is inverse of this and this element is inverse of this. This is our definition. Also we can check their commutativity. B inverse A inverse into AB is equal to you can try this. Same procedure. B inverse A inverse A into B, B inverse A inverse into A is identity element, then B inverse into identity element, B inverse into B, and then B inverse into B is identity element E. So here we observe that B inverse A inverse AB is equal to E is equal to AB into B inverse A inverse. So by definition of inverse, inverse. So by definition of inverse, AB inverse is nothing but B inverse A inverse. So this is very simple proof. So theorem is over. In next lecture we will discuss okay. So here student, our unit first is over with this theorem. So you prepare yourself this whole unit. We have already teach each and every concept. Be carefully. In next lecture we will start chapter 2. Thank you very much.